Hello, everybody. Everybody doing all right this morning? Got some breakfast and some coffee, hopefully, in you. Yeah, awesome. Okay, so I came today to talk to you about Security Onion, and really the basis of the talk is for those who are somewhat familiar with it, but if you're not, it's still okay. I'm still going to talk about what's beneficial about Security Onion and also some other great open source tools that we can use to leverage the strengths of Security Onion. So a little bit about myself. I'm a husband and father of four kids. Yes, crazy kids. They actually came with me today. My wife and kids are both here today. They're not in the room right now, but she's been very awesome for helping me take care of them and having them come along and do the dang thing. So I am also the co-manager of household operations, in case you didn't know. I'm a coffee, Indian food, and free and open source software lover. I love open source software. I love tying it in, more software in with Security Onion, right? And just experimenting with stuff in general, just to find new and interesting things. And of course, as Justin mentioned before, I'm a senior engineer at Security Onion Solutions. So obviously, Security Onion Solutions. Yeah. So a brief introduction really to what I want to talk about today. It's really been a shift in the last few years and probably the last 5 to 10 years in this whole great big firewall thing, right? Where we expect this great big firewall to save us from everything and nobody bad can get in and we're perfect, we're good, right? No. Okay, bad guys are gonna get in at some point and we have to be prepared to defend against that, right? So a lot of these reports you see today, from Verizon and other people about dwell time, about all these attackers dwelling in your environment for a certain amount of time without even being detected. We have to increase our time to detect and be able to respond quickly. And that's what Security Onion and these other open source tools can allow us to do. So we want to substitute detection for prevention, right? When the bad guys get in, we need a way to find them. We want to know. We need a way to get data about our network so that we can make these determinations. We need to have context also. So we need to understand that when we get this IDS alert or when we see this other thing happen in our network, that we have data around it and we're able to scope that event to a particular set of actions or activities. And this really comes down to implementing something like NSM or network security monitoring, but building on to that. So Richard Balick, I'm not sure if you've read the book Practicing Network Security Monitoring, pioneer in the space, call him godfather of NSM, super awesome dude. NSM, in the past has been great. It still has benefits, but we need to build on that and evolve the NSM. We need to implement enterprise security monitoring to do that. So that means bringing in all this other types of data, like host data and other telemetry, to augment that and to help us make a more informed decision. So a little bit about Security Onion. I'm not going to go into architecture a whole lot. It's really going to be more around the data and understanding that. So we can see here that there are various types of data that Security Onion provides by default. Alert data, so you're talking snort, suricata, IDS signatures, alerts generated from that. You're talking about full content data, maybe PCAP, so we're recording the whole conversation off the wire. But again, this is only related to those network-based devices or network-based communication, I'm sorry. And then also we're bringing in host data. So we have the native capability with Security Onion to bring in logs, host logs from Wazoo, which is a fork of OSEC, if you've heard of OSEC. Anybody heard of OSEC? Okay. Okay, it sounds like you guys are a little familiar. So we've got that kind of host data, so we can look at those Windows logs, other host logs. We've got Sysmon data. People use Sysmon. Awesome. Swift on security or Olaf Hartong. Yes. Yep. Awesome. Okay, so all that stuff. Josh Brower did some great work with auto runs, so you can bring that stuff in there as well. Sorry, I keep going in and out with this mic. And then we've also got the capability for doing alerting, like email and Slack, and going to external scripts and stuff like that. Elast Alert is a really great mechanism that ties into Security Onion on the Elastic Stack that can really help us facilitate that. And of course, you've got the data enrichment and visualization. So looking at all these pretty charts and graphs and really summarizing all of this traffic is available natively in Security Onion as well. So I'm not going to spend too much time on this, but again, the alert data, you might see a snort alert, suricata alert. It's basically just a predefined signature or a determination based on certain characteristics of that traffic, right? So it may be of significance, it may not. Moving on, we have session data. So this session data, Bro provides the session data along with other types of great data. This is going to give us, similar to NetFlow type of information, but it's going to identify the type of traffic. It's going to be used to correlate other activity through the Bro logs to other types of logs. So it's very useful when you're trying to correlate different types of traffic between one another, and especially in Kibana, we have that capability to pivot on that con ID and the UID to different scenarios. Transaction data, I'm not going to spend a whole lot of time on, but really it's going to be, like the type of traffic, like HTTP traffic or DNS traffic, or certain things like that. And if there's a file associated with that, there's a unique file identifier that can also be tied to that, and you can pivot to that to see those other types of logs or related logs in Kibana. And I'll show you that here in just a minute. Also extracted content. So Bro, by default, we extract only EXEs from the network traffic with our extract.bro script for Security Onion, but you can expand that to extract other file types. So what that means is that Bro is going to extract those files off the wire. It's going to pull them down. It's going to assign that unique ID, and you're going to be able to tie to that by that FUID. So it's going to have that basically in the file name. So I'll show you a little bit more here, but you can see there with the extracted field, if you can see that, you can see where the identifier is, and then we also have the identifier in Elastic. So if we want to pivot to from that, we can see other related logs. And more so, these extracted files, we can do lots of things with them. We can send them to Cuckoo Sandbox. We can send them to Strelka or have Strelka pick them up. I'll talk a little bit more about that in a minute. It's a file analysis framework. But again, well, not really again, but just be careful about what you're extracting, because you don't want to extract everything under the sun, or else you will have your sensors burned to the ground. I've done it before. Please don't do it. All right, so a little bit more on the full content data. This is going to be that PCAP, and from Kibana and from our Security Onion tools, we can pivot directly to this PCAP from a connection ID. And it's very useful if you're looking at an IDS alert or something else where you can pivot from that alert to this type of data and really get a better picture. So it's just pretty awesome to have that type of thing. Yeah, and to go back, of course, you can manually carve objects out. You can pivot to Wireshark as well. So if you want to, go from an IDS alert and pivot to Wireshark, the PCAP, you can carve different files out that way as well. So the host data I talked a little bit about earlier, I mentioned, you've got the Wazoo, and it's going to perform file integrity monitoring on any host on which it's installed. Also, you can pick up Windows logs, you can pick up the auto runs logs with OSEC, you can pick up sysmon, you can do a lot of things with that, as well as WinLogBeat, which is going to be native to the Elastic Stack that we integrate with Security Onion. So it makes it super simple to pick up those logs and have them shipped over to Security Onion to provide that greater context. Now also we have FileBeat. FileBeat you can use for other types of logs, such as like web server logs, like IAS, things like that, and ship those back into Security Onion. And also OS Query. I'm not going to talk a whole lot today, but OS Query is also very powerful. I specifically haven't done work to integrate OS Query with the current platform, just because we are working to include it with our next generation Hybrid Hunter platform. It's going to be a pretty awesome tool to use to basically query your endpoints, so Mac, Linux, windows, and then pull all that stuff back immediately to security engine, or be able to pivot back and forth between that and quickly identify what's going on in certain situations. So I mentioned alerting a little bit. So ElastAlert is our mechanism that we use primarily for alerting with security engine. With ElastAlert, we can query Elasticsearch, and we can look for certain types of documents or certain types of behavior, and then we can output alerts to maybe email, Slack, Jira. You can do MISP, the Hive, tons of stuff, tons of endpoints, and with your own Python scripts, you have it call that Python script, and you can pretty much make it do anything that Python can do. So anything with an API. Another thing to touch on the alerting. Anybody heard of Sigma? Sigma rules? No? Okay, so Sigma rules are a generic, basically like kind of like a generic signature that you can use across multiple platforms. And in this case, it's looking for Cobalt Strike DNS queries. And we can implement that with security engine. We can use the converter tool to take those base Sigma rules, and we can convert those to ElastAlert rules so that we can use them and have them be compatible with security engine's version of the Elastic Stack and ElastAlert. So it's pretty awesome to be able to do that as well. And you can even tie in MITRE ATT&CK framework techniques and IDs in the alert, so you can be tracking that as well. It's very useful if your organization utilizes that. And of course, the enrichment and visualization I spoke of, really with Logstash, you can do a ton of stuff, interact with HTTP endpoints, memcache, other types of lookups to enrich the data, and just add additional context, again, to that data and pump it into Elasticsearch and make that all available within that single pane of glass. Now, I want to talk a little bit about MISP, because MISP is pretty awesome in my regard. Any of you use MISP at all currently or heard of it? Okay, cool. So MISP is an open source platform for sharing threat intel. I know a lot of organizations that use it currently, IOCs and stuff like that, take them with a grain of salt, but, I feel like they still have some use. And I think a platform like this can be helpful, at least. It's free, and at least give it a shot. So with MISP, you have the ability to import and export different data types. It's got a super awesome API. Basically, what you'll see in MISP are different types of events. So an event will typically contain these details, like an owner, organization, email, threat level, all this type of stuff. And then these events, basically, we can add them in manually or have them imported from feeds. So if we have certain feeds from other organizations that we partner with, we can have them we can sync up with their feeds and then have that type of data pulled in and then leverage that same threat intel. So it's pretty useful in that regard. And we can even attach different attributes. And a lot of times when you see these feeds, they'll have certain attributes attached or certain tags, maybe like C2 or domain fronting, or some type of indication of what the feed is relative to. So you can contain, an event can contain many different attributes, many different types of attributes as well. And we can also leverage that with security, and I'll show you that in a minute, to, once again, add more context around the events that we're looking at in our network. So the feeds I mentioned, a couple examples were the Zeus IP block list, also malware domain list, and fish tank. There's tons, like hundreds of different feeds available that you can pull in. I wouldn't recommend pulling all of them in, because once again, kind of like the bro stuff, you'll kill everything. So you can integrate, your own custom feeds, and you can also export attributes from these feeds and export them as IDS signatures and use them with Snort or Suricata or Bro. So it's pretty cool to be able to do that as well. To talk a little bit more about that, this is what we see here. This is the export panel, and all these different types of exports. You've got Sticks, Snort, Suricata, Bro. It's pretty awesome to be able to pull those in through an automated mechanism to security onion, and then use those to detect things and alert on things. And then also refine that threat intel lifecycle, right? I mean, because everything is not going to be, 100% legit. You're going to have that process that you go through, but it's still helpful, I think, in that regard. So the MISP API is, like I mentioned, pretty cool. They have the PyMISP client. So this is their client that they maintain for you to interact. It's a Python client. And you can implement this in any of your scripts or just use their example scripts together. And like I mentioned with ElastAlert, you can do the same thing. You can use ElastAlert to utilize PyMISP, that library, and interact with MISP to initiate automation, download those NIDS rules, perform Elasticsearch enrichment. I'll talk a little bit more about that in just a second. You can automatically add sightings to MISP. You can manage users, tons of stuff. So Elasticsearch enrichment, what we can do with that, we can interact with MISP in a way that we look for certain types of attributes or different tags, and we can pull those attributes down that are associated with those tags. And utilizing memcached as a local, basically a local database, in-memory database, we can search memcached with Logstash, and then we can pull that stuff in and augment the data in our current pipeline. So we can see if we have a MISP match inside of Kibana. So it's pretty cool to be able to do that. I'm going to show you that in just a minute. As far as the flow goes, we have it right here. So we've got MISP. We're basically using a Docker container. It's a Python script that I've put together, MISP to Elastic, and we're querying the MISP API. We're storing the attributes in memcached, and then we're having Logstash perform that lookup and then populate that data and pump it into Elasticsearch. And then from Kibana, we can see all that kind of good stuff. Again, with the NIDS rules and the bro intel, we can interact with the MISP API again and pull all this types of stuff down. And we can populate it on our security onion instance and then feed that to all of our sensors. And you'll see the link down at the bottom. We've got some stuff here, some directions on how to do that. And we can do the same thing with the bro intel. Excuse me. If we want to have bro raise a notice on any MISP matches, then we can do that as well with that intel.dat. And a little bit about the flow here, as you can see, we're interacting with bro. So about once a day in the morning, we would pull new NIDS rules and new bro intel via the MISP API, and then we populate that out to our sensors. And then from there, we can alert on and detect via those signatures that we downloaded from MISP. All right, so before I go into Strelka, let me show you real quick. A little bit of stuff I talked about earlier. All right, so right here. So in this case, I've had the Logstash config basically write out a field called MISP match. If we find any matches to any tags that we're looking for in MISP. And right here, if we expand down right here, looks like we found a few hits. And this MISP match right here is a tag called "This looks suspicious to me." Now, this is just an example tag. Of course, you might see stuff like I mentioned before, like C2 or something else with some of the other default feeds or whatever your organization uses. But it's a great way to tie all that stuff in with Kibana and Security Onion and be able to see all that, right there in that view. And I'll show you real quick where that is defined in MISP. So I actually have a test event here. And if I look at it, this test event, the info is called "Something Bad is Happening Here." Okay. The super secret default admin password. If I can ever type again. Let's see. And if it's not broken. Okay, cool. So again, this is an example of a MISP event. And I've got various attributes down here that have a few different tags. I got a few IP addresses, IP dest, IP source, and domain. You can see bad guy was here. So this looks suspicious to me. So you can see this IP destination right here, 145, and then this also 172 address with the .20 at the end. We can see that right here, and we go back and verify if I can see it. Yeah. Okay, so it was one of our destination IPs, the 145. So we can see there how it basically did performed a lookup and consulted memcache, and Logstash essentially populated that event during the pipeline. And now we can see that in here, so it's pretty cool. And also, if you want to make a super pretty dashboard, I didn't really do an awesome one, but yeah, I don't know. I just do a couple visualizations on there for you. But anyway, you can take this as far as you want to take it. This is by no means exhaustive. There's just a world of opportunity with that, so I think it's pretty cool. All right, so Strelka. Strelka is a file analysis framework or a file scanning system. It can basically be pumped a bunch of different files or read from a directory if you want, similar to the Bros extracted directory. And then you can take those files, collect all sorts of different metadata and all sorts of different information about those files. And then we can send that again to SecurityOnion and provide greater context. All right, so it's essentially Go and Python 6 and gRPC. Josh Liberty is the main developer behind this. He works at Target, works with the CFC out there, their open source community. He does a lot of stuff out there, so he's super awesome. Go check him out on Twitter. I think it's I didn't put it on here, but I think it's JSHLBRDI. Yeah. Anyway, so Strelka works, it has a set of different scanners for the files. Different flavors and tastes really are how it works. For MIME, there's libmagic, which determines which, I see a typo over there, which determines which scanner to use. It also works with Yara, so the Yara flavors will determine what type of files that it's trying to scan, which is pretty awesome. And there are also external flavors that you can assign, by specific file requests, like if you do like an ad hoc request or, through other mechanisms. Won't get into that. But, a lot of different use cases for Strelka, extracting nested files. So if you have like, containers or zip files or things like that, it can extract out of there and get metadata about those files, identify malicious scripts, suspicious executables, specifically like the Maco and MZ files, executables for like Mac and, Windows. It can analyze those segments and those ELF files, and you can get all sorts of great stuff from that. And also, again, interacting with different things. You can interact with stuff like Cuckoo Sandbox or MMBot, and MMBot can basically give you a maliciousness prediction as to if it thinks like a docx file is malicious or not. So that's pretty cool as well. And some of the scan results, I know they're kind of hard to see. I just figured I'd throw them up there anyway to torture you. They're in JSON format, native JSON. You can choose snake or camel case if you want. I chose snake case because that's how I roll. Built-in management and compression, so it's pretty cool for it to be able to manage its own files and not have to, have your own management process in there. So it's very useful. And tying this in with SecurityOnion, as I mentioned before, pick up those Bro extracted files and get metadata about those and pump that into SecurityOnion. Look at it in Kibana and get value out of it, right? So you can correlate that with the Bro logs already in SecurityOnion via that FUID. So let me go in there real quick and I'll show you that. So, all right, so we got here. So this is just an example of what it looks like from the Discover pane. So this is going to be kind of like Splunk, where you would search if you're not familiar with Kibana. But we've broken all this stuff out that Strelka provides. You can see different attributes about the file itself, the depth. So if it was a zip file, it might have a depth greater than 0. All this other good stuff. The MIME type, what Yara determined the type to be, and all sorts of EXIF tool data as well. So we've got all this EXIF tool data over here. that we can work with if we want to get really deep down and look at the file like super in depth and be able to correlate like some network activity with a file and then go look at really the, the deep characteristics of that executable file or any other types of files as well, like text files, you name it. And we also actually have, I don't have it mapped right now, but you'll see the scan entropy. So it'll also give you an entropy calculation. I think it uses Shannon's formula. But it'll give you an entropy calculation about the file. And of course, you can use that to help make a determination about, if it's packed or things like that. And let me go over to my dashboard because I got a pretty dashboard. There it is. So once again, you can spin up a super awesome looking to management dashboard, right? But I mean, it can really be useful, folks. I mean, you can have I prefer data tables because they aggregate stuff a lot better. And it's like, you don't have to try to decipher the graphs and everything. But, you basically pick and choose what characteristics of those files that you want and that you think can be useful. And like right here, we've got imp hash. So it'll also calculate an imp hash, based on the import table and stuff like that. From those Windows executable files, you can see that stuff here. There are other like MD5, SHA-256, what is it, SSDeep as well. It does all sorts of different hashes on it. So it's pretty cool to see that as well. And let me show you what I was talking about before about the FUID. So each one of these logs, go back here. So you'll see this FUID. If I click this, I'm going to pivot over to a indicator dashboard or an indicator dashboard, I think. Yeah. And then from there, it's going to show us all the related log types. Like we see a bro files log, which is going to be related to that file that was extracted initially. We see the bro HTTP log, which is going to be relative to the, basically the transport mechanism for that. And we also see bro's portable executable log. So that's going to be related as well because it's a portable executable. So we see all these types of stuff and we can tie that together. And again, more context, right? So we get all this great stuff to make a pretty informed decision. So super cool. All right, let me get back to this stuff. All right, now moving on from Strelka to the Hive. Who has heard of the Hive? All right, anybody using the Hive currently? Anybody using Security Onion and the Hive? No, okay, you should. All right, so the Hive, if you're not aware, it's a open source security incident response platform. If you use something like RTIR or fast incident response or just an incident tracker, it's similar to that, except a little more powerful. It can tie in with MISP really well. You can correlate events in MISP with different case attributes or observables in a Hive case. So that's super awesome. And it also has a super awesome API. Seems like a common theme here. All right, so the cases, basically when I think I was modifying this and I made a mistake. But basically, the Hive cases, so essentially, a lot of folks like to have alerts first. I prefer to have the alerts and then merge them into a case. Basically have an external mechanism alert me and then merge it into a case. But, you can also just create cases off the rip. So typically they're populated to include one or more observables, which are going to be like a domain, an IP address, a hash, a file, you name it. And you can also assign different tags or other additional information to that case. You can assign that case to people, assign it to yourself, update it, of course, just like you would in most ticketing systems. And you can also create case templates, which are pretty cool. So if you have a certain playbook that you use, right? Playbooks, people like playbooks. If you have a certain playbook that you use and you do it all the time and you don't want to have to remember the steps off the top of your head, or you've got new analysts that you frequently train or interns, make a case template and then you can have that apply whenever a case has certain attributes or certain tags. whenever you merge an alert in, then it will automatically populate that case with those instructions. So maybe it's, perform memory analysis, perform disk analysis, pull the cable, I don't know, you name it, basically whatever your organization requires. Okay, I think I switched the order around in here. Anyway, to the alerts. So alerts can be generated from a noteworthy event, basically, or whatever application considers it noteworthy. And it really offers an overview of a potential threat or incident, right? So you want to make that determination, which is why I prefer the alerts, and then merge them into cases. Or you can just discard them, right? You can mark them as red and just leave them on their way. But here we have an example. This is actually forwarded from Security Onion, and I'll get to that in just a second. But just like kind of some dumb alert that, okay, port's changed. But no, I mean, sometimes that can actually be an indicator. But in this case, it wasn't. It was just me messing around. All right, so observables, like I mentioned, can be a file, domain, IP, hash, etc. Okay. All right, and the Hive also comes with a ton of awesome analyzers that you can enable through Cortex. So Cortex is basically a companion to the Hive. It's kind of its back-end analysis engine, allowing you to perform, that correlation and lookups and things like that to, again, gain greater context around an event or around an observable, really. So analyzers include things like Cuckoo Sandbox. You can send it off if you have an observable that's a file, do the file circle dance with Strelka and Cuckoo and all this stuff. You can send it off to DShield if it's an IP, you want to do an IP lookup, get reputation, stuff like that. Gray noise if you want to see if it's a scanner or, botnet scanner or whatever. Joe Sandbox, MISP, Nessus, you name it. There's tons of them. New ones coming out every day. So definitely check those out. Yes, and you can write your own. All right, and again, going on the theme here, it has an API, which is pretty awesome, which is how I got this alert from Security Onion in there. And actually, this alert right here, this was an alert that I actually ran a GR flow, Google Rapid Response flow, and then uploaded the result here into the Hive as an observable. So, think about types of things like that. It's pretty cool to be able to do types of things like that, right? So be able to update or create cases or attach observables on the fly, attach a task to a case, or just raise an alert in general, which I typically do the most of versus the latter or the former. So tying in with that Hive API, we can utilize ElastAlert. And what ElastAlert will do, it will allow us to have an automated mechanism, if so we wish, to alert to the Hive. Basically, we set up some configuration details in here, and we tell it what types of event we want to search Elasticsearch for. So all those events in Security Onion. Whatever types of events, if we want just IDS alerts, then maybe we would do event type snort. If you have 20,000 IDS alerts, wouldn't recommend doing that at all. But yeah, so you can just define observables on there as well. You can attach, like, if you want to pull things out of the event field, like what we're doing right here is we're pulling out, where is it? Source IP and destination IP. And you can pull out basically whatever is available in the event that you're searching for and you're grabbing, and you can populate that in as an observable. So if you want to do a hash, you want to do whatever, you can throw that in there as well. And then, of course, with ElastAlert, as always, scripting can get you pretty much whatever you want. All right, so something I hadn't mentioned is Soctopus, and I know, kind of funny name, but Soctopus is really something that I started to kind of solve an itch for us. So with Hybrid Hunter, the new Security Onion platform that we're working towards, we're actually no longer including Squeal. So if you're currently using Squeal or Squirt, you won't have that same functionality. And Squeal and Squirt, if you're not that familiar with Security Onion, are the primary alerting interfaces. So they offer much like, or they act much like an event queue. And from there, you can expire events, you can pivot to other types of data. But we're basically tying that in now with the Elastic Stack and Kibana and lots of cool other things. So anyway, to get back to what I was talking about before, Soctopus allows us to have that same type of alerting functionality to external sources. And what it is a simple Flask API, and allows you to essentially click a link from Kibana and then send that event, ad hoc from Kibana to the Hive, as you can see that we've done here, which is just a Wazoo event for PAM. Not very exciting, but hey. And actually, let me show you that real quick. So I'm going to show you a couple things about that. If I can get back, why are you doing this to me? Did I close it before? No. I guess I closed it. 168.119. Here we go. Let's go back in here. So that API is basically running in the background in a Docker container, and it's proxied by Apache. So if what kind of event is this? Okay, so this looks like another Wazoo event, right? So if I just click this link right here where it says the Hive, I can from there create an alert in the Hive, right? And so we've got, for this particular event, certain events by default with it, Soctopus, you're going to get more observables than others just based on what work I've done so far parsing it out. And again, it's not super pretty at the moment, but it works. So you can see like the other here is just going to be basically like the sensor name it came from, or the host name from which it was associated for this Wazoo stuff. But if you have other types of events such as BroCon, let me go look at a bro connection log. You get a little bit more detail. All right, so it says we got a new bro connection record, and we got 4 attributes, and we can preview and import it. So we see the original BroCon log there. We also see the source and destination IPs. They look kind of weird there because they've been defanged or whatever. And then the sensor name, and then also the BroCon ID. So, some useful things to have. I'm sure there are some other things that we could put in there that would be cool. But, it's a great starting point for helping to automate some of that initial triage, right? So hopefully, folks can get some use out of that. So another open source tool that we can use is Google GR, Google Rapid Response. So what GR allows you to do is perform at scale, across a large number of hosts, remote live forensics, and you can basically do things like, well, let me wait on that because it's on my other slide. But hey, it has an API. All right, so you can see here with GR, our server component, we have a client connected here, and we've got various details about that. These clients, of course, are installed on endpoints. It can be, Mac, Linux, Windows, and you can basically use these clients. You can perform remote data or file retrieval, and lots of other historical info. So it basically will take a snapshot of different changes across the host as well. So that can be very useful in timelining and doing like retroactive analysis and stuff like that. And in addition, as part of the flows that you can run with GR, on those clients, You can collect things like Chrome history, look for different files. You can look at network connections. You can scan process memory with Yara. I mean, there's tons and tons of awesome stuff that you can do with it. And again, it's all open source and it's free. And you can tie it in with something like Security Onion and, help to somewhat automate that process and get things going much quicker than just having to go ad hoc to all the different platforms. That being said, with the API, has a super awesome documentation actually on the server itself that you can access. It will show you exactly how to make calls to the API. It will show you, basically what you're doing wrong, what you're doing right. It also has a Python client library available, GR API client, I think it's called. And you can query course GR for client information with the API. You can run flows. You can start hunts across all the clients in your deployment. And then, of course, you can get the results for any flows you've issued, and then you can upload that to something like the Hive or your own platform, where you want to continue or start that investigation. So what does it look like all together when we have all this stuff running together? It's pretty cool. It's pretty cool, like I mentioned before, right? So we have the interaction with the MESP API. You're pulling threat data. You're enriching that Elasticsearch data with that. You're also, and this is optional because some folks prefer not to have both, right? And I could see there being some overlap in both, but the NIDS rules and the Bro Intel, so we're leveraging that as well. We're feeding that to our sensors. They're detecting and alerting based on that. We're also seeing that context presented in Elasticsearch and in Kibana from that threat data. And then we're able to use those ElastAlert rules to detect and interact with the Hive and interact with GR to run flows and to initiate investigations. And based off those case templates, we have our way to go forward. So it's really this cool kind of flow that we can use, and it's all free, and I'm not going to say all of it is like, one-click setup, but, without too much effort, stuff like that can be a reality, and you can start to build that detection and response, really refine your life cycle. And so to go back, I want to show you real quick, kind of differentiate. I don't know if I showed you guys, but let me go back here. So yeah, let me show you this one. This is one that I actually generated earlier. This is an event that I had generated just from an IDS alert that I generated from replaying a PCAP. And from that, an ElastAlert rule triggered and then presented this alert in the Hive. So we can see that here, the Hive new IDS alert, and then we can see the actual title of that IDS alert. And then we can see the various other details in there. We can see other types of data like the IP addresses that were associated with that. And then, of course, we can see that it's tagged with ElastAlert and Security Onion. So we know it came from ElastAlert, and we know it came from Security Onion. So it's cool also to be able to determine, what sources you want to consider that when you're doing your investigation, what sources the data actually came from. So, and just to go in a little more detail, let me show you that ElastAlert rule. All right, so this is actually right here. This is my standalone Security Onion box that I'm running. You can see that I'm running all this stuff, all the things. Make sure everything's good. All right, and let me go over here. Is it in here? No. Okay. All right, so yeah, that's terrible. Sorry, you guys can't see that at all, can you? Yeah, it sucks. Anyway, whoever can see, like the one person in the front row, that's what it looks like. Yeah, the ElastAlert rule. So, but anyway, it's a fairly, it's YAML. So folks that are familiar with YAML, familiar syntax, and you might have used it already with the Elastic Stack. So it's pretty cool to be able to do that and alert to the Hive, and of course alert to GR. I know I didn't do a demo with GER today. I actually had a little issue with my GER Docker container not behaving this morning, so I had to cut that short. But as far as the Elastic Alert stuff and the alerting, it's super powerful to be able to reach in, and especially with like the Sigma stuff and the attack IDs to be able to tag that stuff and detect that stuff, and again, gain that greater context. So that's pretty much all I have. I think I probably finished up a few minutes early here. I'd be glad to answer any questions that you guys have, and just let me know. Yeah. Yep.
So I understand security is just a suite of tools.
Right.
They're all interoperate together well.
Mm-hmm.
If we have to use some other tool,
Right.
that's what our company searches.
Mm-hmm.
Like say Splunk instead of Elasticsearch.
Right.
How hard is it going to be to integrate all the other security onion tools? With swapping that one tool out.
Right. So it depends on what you're trying to do. If you're trying to forward like alert data or all the data to Splunk, so you could always use like Universal Forwarder to pick up like bro logs and JSON and like the Suricata eve.json or send syslog over to Splunk. So there's that type of thing. And as far as alerting from Splunk to somewhere else, it's kind of out of my wheelhouse. But yeah, that's basically how we would recommend doing it. Typically is via like syslog ng or installing the Universal Forwarder on the box and picking up those logs. Yeah, and we actually had a lot of folks do that. Like if they use Splunk for their search head, and they use security onion for their sensor components. Mm-hmm. Yep.
So as far as integrating with third-party systems, I've been using security onion for the past 4 years.
Right.
After I think like 1604.56, be able to do third-party integrations by using the debug logs and Squeal, no longer would work now. So I understand you're getting done with Squeal. What's going to be the next step for third-party integration?
Right. So like with Hybrid Hunter right now, we are supporting, I'm not saying that Snort is going away. We are supporting so far Suricata. So that format is going to be in that eve.json. So it's just going to be JSON data. So from there, anything that can pick up JSON, like, pretty much all log shippers, or, send that across via syslog ng with JSON formatting. Does that answer your question?
Yeah, sort of. So that answers like half of it, right?
Sure.
They used to be a universal thing, right? So whenever security onion would create an alert, and you set the alert out to display content, you get an alert that you utilize this like ng stanza to then parse and route.
Right. So all that's really doing is just looking at that alert data. Right, so it's the same data that you're going to get. Like if you're running Suricata, you're going to get that same data from the Suricata eve.json file. Yeah. Yep. Yeah.
Any guidance on scaling this?
Scaling for any particular components?
We tried to run, we were testing Suricata and security onion
Right.
on 10 plus gigabit of traffic.
Uh-huh. Yeah, that I'd probably recommend like a flow-based load balancer and a couple sensors for that. Yeah, 2 or 3 probably.
I was going to ask, are you natively supporting like the index and the Vericom drivers?
No, sorry. Yeah, folks have, we've had a few folks ask us about that, and I've not gone down that rabbit hole myself, and they're expensive, so I can't really experiment, but yeah. I think some folks have gotten it to work, but then it like crashes, and I don't know. Yeah, Kickstarter.
I mean, there are members out there who have cards.
Oh yeah.
Enough places they can send hardware, but you just need to ask.
Yeah. No, maybe I'll do that, but yeah, I haven't experimented with it myself, but I know some folks have and haven't had the best of results. So yeah. Uh-huh. Right.
Is there any way in which all the that intel which has gotten collected can be used to generate events which could help let's say, help validate the configuration of security onion.
Right. Right. Yeah. I mean, like.
Today, what's happening is I have one instance of security onion
Uh-huh.
where I know that that particular sensor is not sending data out, but I have no way to validate that.
Right.
Because maybe it is to do that there is no alert event that is occurring on the sensor.
Right.
I'm not able to get any data out of it.
Yeah.
I want to validate my configuration in some fashion.
Sure. Sure. So, you know, with production systems, I don't really recommend using like we have sample PCAPs, right? I don't really recommend using that on production system, but you can use something like, have you heard of Scapy? Scapy, so it's an open source tool, Python. You can use that to craft, like, you know, if you just want to craft a test packet or something that you know will trigger on certain things. And then we actually have an example on the Read the Docs site. Yeah, so it'll show you like an associated crafting of that packet, and then the associated rule, so you can test that. So you're just saying just to validate that it's working, right?
Yeah, that's one thing.
Yeah.
But what about over a period of time for a specific customer?
Uh-huh.
I have collected enough intel to say that these kinds of events are malicious for that particular instance.
Right.
I want to try and make sure that if I were to upgrade or change the IDS in any way, I'm able to validate that the detection of those events are still taking place.
Right.
I want to be able to, I want something like an event generator, if you may call it that.
Right. Yeah. Yeah. So.
Not one isolated packet or
Yeah.
event. I want a range of events which will automatically be generated in order to help me check my detection system.
Right. Right. Yeah. So you know, there used to be Pitbull used to be a project that did that. It was on SourceForge. I think Peter Menev from OISF, he works with Suricata. I think he wrote a tool that will let you do something similar like that, an event generator. Then there are a couple other ones out there. You just have to kind of scour GitHub and look. I'm sorry. Yeah. Any other questions? No? All right. Thank you guys. Thanks for listening to me. So